Hello, everyone. Thank you for joining us today for this webinar titled Identifying and Implementing Closed Molding Solutions. It is brought to you by Composites World and presented by Magnum Venus Products. My name is Ginger Gardner, and I am Senior Editor at Composites World. Manufacturers are adopting closed molding composite processes for benefits such as reduced waste, lower emissions, and higher consistency and repeatability. With so many processes and options, identifying and implementing the right method can seem daunting. Magnum Venus Products, a global provider of fluid movement and production solutions, has been a leader in closed molding technology since its inception. With equipment, accessories, and years of knowledge and experience working with manufacturers, MVP offers comprehensive solutions and support for closed molding. In this webinar, MVP's technical experts will evaluate a variety of methods, including light RTM, infusion, the flex molding process, and the latest technology called fast flow LRTM. Attendees will receive an overview of each process and learn where each is most effective, as well as tips and tricks for optimizing efficiency. Our presenters today are Charles Tur, Closed Molding Specialist, and Drew Simmons, Regional Sales Manager for MVP. Charles Tur began his career in the composites industry over 20 years ago, and in that time has built a reputation as an expert in the technology of resin transfer molding and resin infusion. Charles has operated his own composites fabrication company, building 50-foot sailboats using RTM and vacuum infusion. He then worked as a consultant for suppliers of advanced closed molding technologies, followed by serving as head of technical support for the French reinforcement supplier Chomera, where he gave over 300 presentations in 30 countries on the light RTM process and was involved in the development and implementation of products such as Rova Decor, Rova Foam, Rovaplast, and more. Charles joined MVP in 2007 as RTM Infusion Technical Specialist, presenting light RTM and flex molding process workshops worldwide. He also supports MVP distributors with consulting, planning, installation, training, and problem solving for customers at their facilities. Drew Simmons is the Regional Sales Manager for MVP. With nearly a decade of experience working with composite manufacturers, Drew has the unique ability to apply his broad technical knowledge to understand client needs and enable MVP's customers with the right solutions to maximize their production quality and efficiency. Drew graduated from the University of Tennessee with a Bachelor of Science in Business Administration, Supply Chain Management, and Marketing. Before we begin, I'd like to remind you to please submit your questions by typing them into the question pane on your control panel at the right of your screen. We will answer these during our Q&A session at the end of the presentation. And now I'm going to hand it over to Drew Simmons.
Thank you, Ginger. Thank you, Composites World, for having us. Thank you, everybody, for jumping on this webinar where we're going to talk about closed mold. First, I just wanted to give a brief introduction of who Magnum Venus Products is, where we've come from. And so MVP has been around for 80 years, serving the composites and adhesives markets. We were founded in 1938 as actually a coatings distributor for a lot of the aftermarket OEM or aftermarket and OEM auto manufacturers. In the 1970s, we saw a need for a manufacturer of composites application equipment. And since then, we've had our focus being a global manufacturer of fluid movement and production solutions, utilizing our direct sales force in North America and then our amazing distributors internationally. Here is a brief overview of some of the composite application equipment that we provide. There on the left, you'll see the chop and wet out and gel coat systems for more of an open mold application. There in the middle, you'll see the injection systems. They're highlighted as our PLC controlled Innovator 3 system, which we'll touch on later. And then there on the right, you'll see some of our pultrusion and then epoxy, urethane, and silicone systems. So a wide breadth of composites application equipment. And then here is highlighted some of our adhesive and sealant equipment. This equipment is able to pump and mix and meter a variety of different materials from single to two component materials with a wide variety of ratios that you need. And then here's just a brief overview of some of our automation equipment, anything from reciprocators, filament winders. We do manufacture mandrels and then also impregnators and also a robotic arm as well. We see obviously the need for automation going into the future. And so we are heavily invested in being able to provide that solution for you all. And then here at the end, before I turn it over to Charles, is something we're really proud of. MVP has recently, in the past few years, gotten into the additive manufacturing. And so this is our RAM, Reactive Additive Manufacturing System. It's the world's first and only large-scale thermoset additive manufacturing machine. And so you may be familiar with some of the thermoplastic machines, but MVP, being a key player in the thermoset composites world, saw the need to bridge that gap. And so we came out with the RAM system, which we're really excited about. So I just wanted to give you all a brief overview of MVP. Thank you for coming. And I wanted to turn it over to Charles.
Thank you, Drew. Good morning, everyone, and thank you to be with us today. So I'm going to talk about my specialty, which is closed mold processes, and they are mainly used to control part quality in production, to be sure that all the parts will have the same weight and the same quantity of raw material, to increase the daily production, and to decrease part costs. Control of the flow resin is the most important aspect for success in the closed molding processes. This is what I'm going to show you. The process selection. So which process is the most appropriate? For that, you need to know what is the part size, the part shape, the part side surface finish. I mean, one side, one finished side, two finished side, both gel coat side, it depends. Part properties. Are you looking for mechanical properties? Are you looking for stiffness only? Part quantity to produce per day on the same mold, and the part quantity total of your full production. Then we can select the process. To introduce the different process, which are infusion, light RTM, flex molding, and fast flow light RTM, I have decided to do that through a case history. We are in New Zealand, a company who produce a rotary platform to milk cow. These platforms are lightweight and made in composite. These support delivery around the world. So for that, you have different size and different product to produce. So the platform assembly details, you have all the composite part fixed on the metal structure because the platform is rotating 360 degrees in 5 minutes. So the cow are coming in, they are milk during the 5-minute time, and then they can escape by themselves. It's a fantastic project. And the person who managed this project is Jos Janmaat, which is our MVP distributor in New Zealand. And he started with infusion, classic infusion, then moved to light RTM, and then flex molding process. So let's see all production details. First part was made by classic infusion with all material, including metal structure. First, you have the female mold where we spray the gel coat, then glass loading and foam loading, then everything under vacuum, including the metal structure, as you can see on the top, and then the resin infusion. Talking about infusion, and I will jump on that to show you what we have developed for infusion, we always focus when running development on saving time in production. It's very important to focus on production because each single detail can change the life. So we are on the left, a classic infusion done several years ago for a swimming pool infusion, and actual swimming pool infusion using the injection machine with almost no waste. So the first thing we have developed to be able to inject the part using an injection machine is a valve that open and close as we like, and a sensor. The sensor that we call PPVS will control the internal resin flow during the injection. Why? Because the injection machine has the power to inject the resin on the high pressure that will inflate the bag, which is not good. So the sensor takes care about it. And the sensor will open and close the valve according the internal pressure. That can be done with one valve, but that can be done with several valves on the same mold, on the same part at the same time, all pneumatic. So for that, we have connection, a special IFA connector, quick connection, no tacky tape required, no air leak guarantee, and of course, universal to be able to connect all different MVP accessories, which are blank plug, injection pipe, valve, PPVS, and so on. So as we look for production, there is a possibility to use a silicone resin channel that we call collapsible resin channel. By the power of the injection machine, what we want is to send the resin all over the parts on the resin channel. and then after that, have the resin distribution through the glass. So we want this resin channel reusable. We want to be able to put it fast on the mold and to remove it fast, not spending time to remove tacky tape and so on. So for that, we have used an ID developed by an engineer from Netherlands, which is the collapsible resin channel. He have developed that 20 years ago, but never find a way to pass the resin through. So we complete this development by adding a possibility to inject the resin through the channel. So for that, we have the mold, we load the glass, and we come with the silicone resin channel on the top of it. We apply the first vacuum to help the resin flow into the glass, and then we pull a second vacuum to collapse the resin channel. When we collapse the resin channel, then we can introduce the resin, because there is no fiberglass, the resin will flow first into the resin channel, especially with the pressure of the injection machine. And just before the part is finished, as we have a stroke counter on the machine, we can precisely stop to inject the part when the right quantity of resin is injected. And the resin which is into the resin channel will help to fill the part when we will stop to pull the vacuum into this collapsible channel. The membrane will come back flat and you will not be able to see how we have injected the part. So it means you can put as much as you like of resin channel. Then to be able to inject the part, we wanted also to control the injection. Sometimes we have to work in sequential, and we want to be sure that we can send the resin on the right, on the left, according the part. And of course, the raw material. Are we in monolithic? Are we in sandwich area? Then it's not the same injection at the same time, I mean. So for that, we have made a part and developed a free pre-treated mold for silicone casting. So since we have the mold, we can pour the silicone inside, and when we demold the part that you can see, which have a little lips. When the lips are closed, the resin cannot pass through. When we pull the vacuum into the resin channel, we open the lips and the resin can flow. As an example here, we have a blade production where we put a resin channel, which is a 15-meter long resin channel. And we have in the center of the part a monolithic area. So we want 3 resin channels nearby each other. The first one when we will introduce the resin, and when the resin will pass both sides to continue the infusion, we will stop injecting in the middle and continue to inject at both sides. But we want to have only one injection port for the 15-meter blade. So it works like that. We have the single injection port and we pull the vacuum in the central resin channel. Then we can see that we have the possibility for the resin to flow because all the other resin channels on each border are closed. And when we stop pulling the vacuum in the middle and then pull the vacuum on both sides resin channel, then the resin can flow on that area and not anymore in the middle. So we can manage using only one injection port, even large port. So this is the blade. Mold, where we load the glass. On the top of it, in less than 2 minutes, we load the full resin channel. We close the plastic bag on the top of it by tacky tape. And then we inject the parts. So we inject by a single injection port. Then the resin flow in the middle and then both sides. And if we want a next injection port, if we need, we can do it. In fact, it was not required, but anyway, we can do it. The most interesting here is there is nobody around the mold when we inject the part. It's all automatic. So people are free to work on another blade during the injection time. And then when we have to remove the resin channel, as you can see below the resin channel, there is no mark, there is no resin excess, there is no mark, there is no print through, there is nothing. And the silicone resin channel is completely reusable. So this is the blade after it. Then our last development are first we inject the part with the machine. We have the silicone resin channel. We inject the resin on the top. We pull the vacuum in the middle and then on the part border where we have nearby a silicone vacuum channel to suck the resin. And then to close the plastic bag, there is no more tacky tape. We have developed a unique solution which is more safe than using tacky tape. There is no possibility of air leak. So this is very secure. You don't have to care about the fold. You just screw the membrane like that. You put this special solution on the top of it, and then it's done. So that's the evolution of the infusion done by MVP. Now, the second generation of the rotary platform was to stop producing part by plastic bag infusion and move to lighter tin. Why? Because they save time. they move from 20 hours by infusion part to 5 hours. So solution was light RTM. And then we have to look for all the single details of this improvement, because the idea is to save money in production. Instead to use metal structure, they replace the metal structure by a foam structure. As we have a foam structure, we have decided to introduce the resin into the foam. We have created a resin channel into the PU foam, which is not a problem. It's not a big channel, and nobody cares about the resin which is in the foam. It's better and easier to have to remove a resin channel on the top of it, and by lighter time on the countermold, it was not possible. So we had to inject the resin all around. It was complicated. So by injecting the resin along this resin channel into the foam reinforcement was very convenient and very easy. So this is what we have done. Then this is what we do more and more in production. For example, here we produce the door. If you look on the right pictures, then because there is the resin channel, in light RTM, you have to trim it off. And it's boring because it's complicated, it's not nice finish. So the idea, and this is what customers do, is to integrate a little resin channel into the edge of the foam. And when you inject the resin first flow into the channel all around the foam, and then into the glass until the vacuum cache pot. So there is no more resin channel to trim it off. When we demold the part, we just sand a little bit the gel coat and it's finished, saving plenty of time using that kind of solution. The groove can help to introduce the resin, but can help also in a different situation to pull the vacuum and to remove the trapped air in the middle of the composite when injecting the part with foam core. Here we are on the wind blade production. It's a small wind blade. We talk about 6.5 meters. And as you can see, there is a groove into the foam. That part is injected by only one injection port and one vacuum port. And we guarantee no air into the part. Why? Because we use that kind of strategy. In blue, we have the resin channel where we introduce the resin until the 60% of the part. And on the other side, we pull the vacuum. And because we don't want to have any trapped air, we have a little groove that help for the resin flow, but also for the vacuum to pull the trapped air. Then there is no trapped air at the end of the injection, as you can see on that pictures, which have that part which have a clear gel coat. So is a solution we can use on many different situations, and it's very helpful. Then the problem when you have a large part, like on the platform, sometimes you have a lot of glasses to compress. You have a foam core, you have sandwich, you have glass, and when you approach the countermold don't touch properly the female mold on the flange, and then it's impossible to pull vacuum and to close. So you start with a clamp and so on, so it's not easy in production. So we had to find a solution. This is why we decided to move on the vertical flange, adding a second wing seal. So it's working like that. When you come with the countermold, the first silicone seal on the vertical side will touch the flange border. It will slide on it. And then because it touch, you can apply the vacuum. And when you apply the vacuum, everything is moving down like a piston, like a press, until the countermold touch properly the female mold. And then we can inject the part by respecting the right part thickness. So all this solution help a lot for the production, as you can see. It also helps to locate the countermold, and it avoid that people will come with hammer and metal to demold the countermold. We take care before to apply properly the release agent, and we demold by air, removing one of the valves, and then it's fine and it's working. So we do that for the large part. Then we go for the next generation. Again, looking for saving time and money. Sandwich core material is expensive. Metal structure and foam and so on is complicated. So they have decided to make a corrugated part to reinforce a flat part which has no core material. So just flat composite reinforced and bond on the top of it by the corrugated part. So for that, we have to develop a possibility to inject the part faster. Just a resin channel all around the corrugated part will be very complicated because you cannot guarantee that the resin will arrive exactly in the middle. Why? Because if you want the resin to arrive exactly in the middle of the mold, you have to play with the flexion of the countermold. And here there is no flexion. So because the parts are bonded together, we decide to leave the resin channel on the part. Nobody will see it because they are below the corrugated part. And the weight of the resin channel, I mean on the resin into the resin channel, is not very high, it's very few resin, but it helps a lot to increase the production, decreasing the injection time. So this is what we have done for the corrugated part, but also for the flat part. You can see here all the resin channel. So that was working very well. And of course, to bond the part together, we have our adhesive dispensing system, which is very, very convenient because you come, you put the adhesive, and then you bond the part together. That's worked beautiful. Now, after that, and because they are located in New Zealand, always focus on improvement, they go for the third generation. The third generation is flex molding. Why? Because they are not going to make anymore a corrugated part. They decide to produce a flat part as fast as possible. And then they buy a prefabricated pultruded profile that they bond on it. And then that was very easy, very fast. With the machine to bond, and it's very fast to bond everything on the top of it. And because of the silicone, there is no release agent on the surface, so you can bond easily. You don't have to sand, you don't have to do anything. So flex molding is working like that. So for that, we have an injection machine, accessories, and silicone machine. Maybe, Drew, you want to say something about the silicone machine?
Yeah, absolutely. So, one thing I want to point out is anything in the process, the ones Charles has walked through and he will walk through, from infusion to light RTM to flex molding, we have equipment that can be utilized in any of those processes. So we have built the equipment. We have a pneumatic version of our injection machine, as well as a PLC controlled based machine, if you're interested in capturing and controlling the process as much as possible. We have a line of accessories, like Charles mentioned, with the valves to ensure that the injection goes smoothly and there's no unforeseen instances that happen that cause you to lose a part. And then also for flex molding and other applications as well, we have a silicone machine that you can use to actually build the silicone bags. One of the nice parts about that machine is you can pour as well as spray with it. So you can really do a wide variety of different parts and pieces with it.
Thank you very much, Drew. So then this is the details of the membrane. On MVP, we have decided to work with the groove on the female mold for the closing system. Why? Because here you see a little membrane, but you have larger membrane, and the fact that you can load the membrane into the groove help to tight it when pulling vacuum, that you guarantee that the membrane is positioning on the right area before you pull the vacuum and inject the part. So it's very helpful. Of course, we have to make a groove on the mold, but we have solution for that I'm going to show you. So then in the middle, you have the collapsible resin channel, which is invisible. And then you have a little vacuum channel to pull the vacuum only with one port. So one port to connect the resin, one port to pull the vacuum. Easy. So the groove is working like that. You have the groove. Then you load the gel coat and the fiberglass on the mold. Between the fiberglass and the vacuum channel, we load what we call a resin stopper, which is a little part of Coremat. Why? Because the Coremat will stop the resin, but you will continue to pull the vacuum through. If we use any other kind of material, when the resin passes through, there is no more vacuum, and that's not the best for the part. So then we come with the silicone membrane on the top of it. We will first apply the vacuum on the groove, and that will suck down the silicone membrane into the groove. We guarantee zero air leak. Then after that, we apply a second vacuum to suck the vacuum into the resin channel when injecting the part. So the resin is coming, we'll stop on the resin stopper. So it means when we demold the part, there is nothing to clean, there is no pipe to remove, nothing. You just remove the silicone membrane, demold the part, and produce the next part. So to help customer to produce the groove, we have developed a seal, which is a two-part seal. We bond this seal on the mold pattern, where we respect a minimum of 90 millimeters radius on angles. And then when we laminate the mold and demold the mold, we talk about the female mold, then we remove only one part of the seal and we leave the other one on the groove. Then on the top of it, we are going to pour the silicone with the machine and then to spray the silicone, building the membrane, as you can see on that pictures on the right. With our machine, of course, we can spray and pour. And the big advantage of this machine is that machine is big enough to go for the big part and not too big to go for the small part. It's perfect design for it. So when we demold the membrane, what we have to do, we just have to remove the second part of the seal. In fact, that seal has created the vacuum channel that we need below the membrane. So then it's very convenient, and that seal is completely reusable to produce a new membrane. So then we work with the collapsible channel, as you can see. So we inject the part, and when we finish the part, as you can see, there is no mark, there is no resin line visible. There is no print through on the gel coat and no resin waste. So to create the vacuum channel, we use this white foam seal, which is a window seal. Is adhesive, self-adhesive, so it's easy to bond it on the technical flange. And then we start by pouring the silicone into the groove. And then we build the membrane step by step in 4 layers. Why we do that in 4 layers? Because we want to guarantee there is no micro porosity. Then we reinforce the membrane by using a technical cloth. A good membrane is around 3 millimeters. There is no need of more. Then after that, it starts to be too complicated, too expensive, and the weight of the membrane is too heavy to work well in production. So for that, we have 2 kinds of cloth. We have a stretchable and a non-stretchable. The non-stretchable will be all over the surface, and the stretchable will be only below the resin channel. So then when the membrane is built, after that, we come with the half plastic corrugated tube to create the collapsible resin channel. So it's easy, convenient. We just bond it. And then after that, we come with 1 layer on the silicone and the cloth on the top of it to tight it. Then, of course, we will put some things and glue some metal insert to lift the membrane according to the size of the membrane and the production. Some people like to roll the membrane. Some people like to lift. That's not a problem. Both are possible. Here, for example, we roll the membrane. It's a, I think, 7-meter long membrane with a single injection port. So we load the glass, we load the membrane, we pull the vacuum into the groove to tight the membrane and the vacuum to help the resin flow. And when we demold, again, on the right pictures, there is no visible resin channel, no resin waste. Everything is clean. No need to clean the mold, no need to clean the membrane, no need to change the pipe. And then, of course, we produce the part with the collapsible resin channel and the injection machine. As you can see, the people around, there is nothing to do. The machine will inject the right quantity of resin, will stop when it's necessary. And we have a special valve that will stop to pull the vacuum and let the air coming into the collapsible channel when the valve will stop, when the quantity of the resin will be injected. It's all automatic. And then when we remove the silicone membrane on the bottom pictures, again, you can see everything is clean. And this is the Waketo rotary platform that they sell all over the world, China, USA, sorry, South Africa, India. It's a good business, and they work very, very well on that project. It's very representative of the composite, closed mold composite business. So, of course, we have different examples of flex molding. Here we have an example of the company Marcos, who produce part of a nacelle. Unfortunately, I have a lot of beautiful pictures on my computer, but you know at MVP, we respect confidentiality and we don't have any authorization from customer to show all we have. It's a shame because you will love to see it, but we have to respect confidentiality. It's something very important and we take care of it at MVP. So here we are in the transportation in France, where the composite derisoty, they have produced 1,200 parts with the same membrane. If you want to increase the life of the membrane, you have to take care to not leave the membrane for too long after the gel time. So if you inject the part in 20 minutes, you have the gel time, which is something like half an hour. Then after 40 minutes, you remove the membrane. You leave the membrane like that, the styrene will evacuate. You never leave the membrane overnight or over the weekend on the part because you will decrease the life of the membrane. So then we can go for sequential injection for bigger part. As you can see here, we have 36 square meter part where the customer produce a water reservoir panel that they will transport all over Europe and assembly and screw it together to create the reservoir. So there is many different applications with the flex molding. And talking about that, we can go also buy the silicone membrane for part with undercut, which is impossible with a rigid contour mold. So here we are in Thailand, the company Cosmos, who produce dashboards. And here we are in Scotland with a company who produce a bus dashboard. If you look at the complexity of the part, even if you find a way to produce it, the mold cannot be in one part. This is a split mold. So we had also to develop a solution to build split mold. So for that, on each section of the female mold, which are 4 parts, we have created a channel. On that channel, we are going to pour by ourselves and with our machine a special silicone, which is a 3-minute gel time silicone, which have a special form. Even you can pass a straight angle, as you can see on the bottom here on the right picture. Then we are able to assemble this part together under vacuum. So we spray the gel coat, we load the glass, we load the membrane, everything is assembled by vacuum, we inject the part, and when we demold, we get it. The only way to assemble the mold is vacuum, because when you inject by vacuum, if it's not tight, then you are full of air. Now, after all this, I would like to introduce to you, our new development. We have some requirement from customers who work with, for example, filled resin, fire retardant resin, and recently PU resin. Some of the resin have high viscosity. We talk about something like 600 centipoise. The problem when you work with a filled resin is the filtration. When the resin flow distance is too long, then you have a filtration of the filler, and then the part don't have the same properties everywhere, and this is an issue. Second problem is when the resin has a very fast resin gel. So in this case, you have to be sure that you inject the part in less than 4 minutes, which is the gel time of the PU resin we have done. So we develop a solution which is between flex molding and light RTM, a combination of silicone and light RTM. So first, when we inject on the glass table to check the distance of the resin flow, we find that with a resin of 600 centipoise, with, I will say, 30% glass content, like an injection mat, the resin will flow in 4 minutes for 30 centimeters, but in more than 20 minutes for 80 centimeters. So, of course, we want to work as fast as possible. If I take a part, for example, here, and I use a classic light RTM, where I inject the resin all around into the resin channel, the resin will flow that distance and that distance at the same time, which is around 80 centimeters, and it will take more than 20 minutes. But with the fast flow light RTM, where I can integrate the resin channel into the contour mold, because the surface is silicone, I have only 30 centimeters for the resin to flow. So I can inject this part in 4 minutes. So this is what we have done here to try it. We pull the vacuum into the resin channel. We inject with the machine. This is a glass table to see the resin flow. And then we inject the part very fast. So we have decided to do that as a demo mold. And this is the way we produce the contour mold. We have the female mold below. We have a calibrated part. And first we build the membrane on the same way we build the membrane, but we put more resin channel to decrease the resin flow distance using our special resin port in the middle. Then we build the membrane. And MVP has developed a unique solution to bond composite on silicone. Doesn't matter the size, doesn't matter the part, composite will bond on silicone. So this is what we do. We hand laminate the composite on the top of silicone, or we just infuse the composite on the top of the silicone. Both works. We do that because sometimes for big mold, people prefer to infuse. Then when we develop, as you can see, on the top pictures, we have the vacuum into the resin channel, and on the bottom, we stop the vacuum. But you have a rigid contour mold. So it means we can inject the resin with a higher pressure. First, by the pressure, the resin will go into the resin channel, and then after that, will flow through the part. And the surface that we get is almost the same as a light RTM. The other point, which is very interesting on that process, is that you can stop precisely the resin on the part border. It means there is no need to cut the part or to trim the part after demolding. So what I have put here after the glass load properly on the part border is some little part of peel ply to suck the air, but to stop the resin where I want, only where the resin arrives last. So then we close the mold as a light RTM, same things, we pull the vacuum on the flange. Then we load our turbo auto spool, which is our injection valve in the middle, and we just inject the part very fast. So we know the quantity to inject, and that kind of part with a standard polyester resin injection, it takes 2 minutes, and with a higher viscosity resin, 600 centipoise, it takes 4 minutes. Then, when we demold the part, as you can see, there is no visible resin channel, because this is flex molding and collapsible resin channel. no resin excess, nothing to clean, and no trimming needed. This is the part. You just have to grind a little gel coat of fiber that pass through, and that's it. So this is the process developed by MVP. We always focus on production details and on customer requirements. Every year we develop something new because it's very important to have an eyes on the customer requirement. Anyway, one thing I would like to show you before I finish is that even we develop with you and we introduce to you a wonderful process, closed mold application and so on, you need to have a good organization around. If you don't have a good organization, then it will be complicated. This is fundamental for money and time saving, but also for production longevity. You don't want to produce for 1 week, you want to produce for years. As you can see here, they have made a metal structure just to spray the gel coat and to load the glass. Here, they have oriented the mold to make easy the job of the people who will load the glass. They are lifting the membrane to be sure that nobody will walk on the membrane and will damage the membrane. You can see the floor is clean. We also recently developed, because we are able to bond composite on silicone, we are also able to bond silicone on composite. It works on both directions. Then we saw that customers use a tape, masking tape, to protect the flange when spraying the gel coat. And it takes a lot of time, a lot of energy. So we developed that, which is a composite and silicone part that will be used as a flange protector. So you just load it on the mold. You trim the silicone where you want the gel coat to stop. And then you spray your gel coat on the top of it. And the excess of gel coat you will have on the flange, at the end of the day, you peel it off from the silicone because it's self-release. So it's very easy to do. That is also a solution that MVP provides on training and on presentation. And then, of course, all the vacuum installation. As you can see, everything is coming from the top because there is nothing on the floor, no pipe on the floor. So the mold are free to move to the gel coat cabin without problem. And then, of course, we have also the robotic solution. For example, here we are in Pauling Water Park, which is the second biggest producer of water park in the world. They have more than 1,500 lighter tier mold and flex molding mold now. They produce around 200 mold every day in production, and with many different colors. So for that, we adapt for them a gel coat, 2 robots with 8 different colors each. So first, they have a mold barcode recognition, then robot spraying the gel coat, and then 16 MVP gel coater connected to the robot. The robot can change its color by itself without the human help in less than 1 minute. So this is all this solution that provide MVP. So we will be at the CAMAX, and we'll be happy to see you there.
Yeah, I just wanted to mention, thanks, Charles. One thing that I just wanted to key in on with Charles and just MVP. We are totally focused on customers' production, right? So we would love to hear from you at CAMX. Like we see there, we'll be at booth AA28. Come see us there in Dallas. Also, MVP is a part of what's known as the Closed Mold Alliance. And so there's also a big demo zone where you can see a lot of these processes demonstrated with MVP equipment and other partners as well in the industry. So if you're going to come to CAMX, come see us at the demo zone with the Closed Mold Alliance. We would love to see you there. MVP is totally dedicated to you, the customer. And so please reach out to us with any information that you need. As you can see, Charles has developed a lot of things through the years for customers. And so if you think you have something that we can help with, please reach out.
Great. Thank you so much, Drew and Charles. That was a great presentation. We do have questions from our audience, so we'll get started with those. And in the meantime, please do submit questions, and we will get to those. If we don't get to everything while we are on the air, this webinar is being recorded and will be available online. One of the first questions: what will be the volume fraction of reinforcement in the mentioned processes? And what will be the maximum reinforcement that you could achieve in these processes? And does it vary? Does it vary by process?
Okay, so that's a good question. First, it depends on the process. It's clear that with a counter mold, you will never get the same that if you use infusion, plastic bag or silicone membrane. Why? Because the glass has to be compressed. The maximum I cannot tell, just what I can tell is that we already produce part with more than 60% glass content. I know people are also working with carbon, and that we have to check what is the maximum of the maximum. But in fact, it's not because we use an injection machine to introduce the resin that will change what we get on the classic infusion. It's exactly the same because we manage the injection pressure during the infusion. So we must get exactly the same that you get on the classic infusion.
Thank you. Are your silicones compatible with epoxy? And if so, what is a realistic number of pulls before it deteriorates?
Alors, no, this is one of the problem of the silicone. Silicone is not compatible with epoxy. It will work for a few parts, 20 parts, maybe 30, but after that, the membrane will be damaged. So no, it's not compatible. It's better to tell it since the beginning. This is why we develop sometimes only the resin channel, because customers say, okay, even 20 parts with the resin channel, it's okay because I just have to redo the resin channel, which is easy to do. But the full membrane, no, is not realistic. It's better to use a plastic bag.
Can the flexible silicone membrane be used on chopped strand mat or only woven reinforcement?
Alors, it's nothing to do with that. When we talk about membrane, can be plastic, can be silicone, the resin has to flow. The resin has to flow through the glass. A chopped strand mat has a binder. When the resin touches the binder, the fiberglass can move. So if the fiberglass can move during the infusion, that will close the infusion. So the glass has to be stitched. And then you have different kind of infusion. You can go by the top using a net on the top of the glass, a net that you will remove after it to get better mechanical properties with less resin. You can have internal flow medium, like the injection mat or different kind of new glass, where the resin can flow. But anyway, that has to be stitched.
Okay. And we do seem to have a lot of questions about different types of resins that can be used in your processes. What resins do you use in your processes? Polyester,
Alors,
epoxy?
Mainly polyester, iso, ortho. You just have to take care sometime when using a silicone membrane about the DCPD resin. Some DCPD resin, the way the producer make it, sometimes they are aggressive for silicone. And then they damage the membrane faster than normal. For example, you take a iso resin, you can produce 500 parts, and then you will take the same membrane, use the wrong DCPD resin, and you produce 50 parts. So you have to take care about it. We're always careful, and we run some tests for that. We start to have a list of resin which is working well and not. Vinyl ester, epoxy vinyl ester work well. We have one demonstration at the GC building a kayak, which is working well. But epoxy, no. Epoxy, no, is not working. We have new kind of resin. We're actually working with a PU resin, which are work well also.
Polyurethane.
Polyurethane. Yes, we have tried also Arkema resin, which is an acrylic resin. Helium resin, thank you. And that was working, but with the silicone, we put some release agent because it's a little bit aggressive.
Interesting. How long can a silicone mold last maximum, do you think? I mean, how many parts have you seen?
1,200.
1,200.
With the same membrane, if you care about the membrane.
Okay. What about temperatures? What is the limit of the silicone in terms of temperature?
Depends of the silicone, but we talk something about 200 degrees. I think you will kill your composite mold before you kill the membrane.
200 degrees C, yeah.
200 degrees C, yes, sorry. I'm French.
Yeah, it's no problem. How do you fix the silicone sheet to the composite structure in the fast flow process?
This is a very good question. As you see on my website, on my last slide, I show the MVP email address. So please, if you have that kind of question, email us. We are not going to answer to everybody like that on that kind of question. You know, it has to be a huge development and investment from us. And that things we will work customer by customer.
And then many people were also asking for the presentation. I would assume you would want them to reach out to you, yes?
Alors, what we would like, if they like the presentation, we have nothing about it, no problem to share it because you see, we put it on internet and everybody can see it. But we would like to know which person we give the presentation. So please email us, and then we will answer.
Yeah, absolutely.
Okay, and according to your country, we have distributor, worldwide distributor. So we will probably answer through our distributor. Like that, you have also the MVP contact nearby.
Yeah, because we had one say, do you have distributors in South Africa? So
yes, we do, of course.
Yeah. Okay. How do you control temperature during the process, or do you? Is that something that comes into play with these processes?
Alors, I have only 1 hour, to introduce everything in 1 hour. It's very short. I'm sorry about that. When we go for a new project, we build the project. So it means we first talk about the part we have to design, to infuse. We have the glass content that the customer needs to use, and then the resin. So we make some glass table tests where we check everything, the resin flow distance, the mechanical properties after debuilding the part, quality surface, and of course, the peak exotherm. And according that, we build the mold according the temperature we will have. If we have to use resin which are better HDT, gel cotton resin, we will use it. It really depends on the package and the resin.
Is there a preference to use a composite tool versus a metallic tool? And I guess they're worried about stiffness, especially if you're using pressure to inject.
No, that changes nothing. Of course, we can talk about classic RTM and high pressure RTM according to the print, but this is another story. What we try to show on that presentation is with a low investment, we are able to inject parts. Okay, so because we control the internal resin flow pressure, there is no pressure inside the mold. So there is no need to use a big mold or big counter mold. But of course, if you want to increase your production, you can go for metal mold, you can go for classic RTM. That's completely possible. It really depends of the quantity of the part you want to produce per day.
Okay. Another question we had is the kind of silicone, but I assume that that's part of the expertise you're delivering, is you've looked at silicones and you've developed the kind of silicones that work best.
Alors, is yes and not. At the beginning, we have used the silicone on the market, and after that, we approach silicone producer to show them what is good, because honestly, the silicone producer composite is not really their business. It's a small business for them, and they don't know exactly what we need. So we had to talk with them to explain more precisely that we need thixotropy, that we need 30-minute gel time to be sure there is no trapped air, that we have time to load the technical cloth and so on. So yes, we approach them, but at the beginning, we take the silicone that we have. And if you look at 15 years later, the cost of the silicone per kilo and the cost of the silicone today per kilo has nothing to do. We are 10 times cheaper today. Why? Because they produce more.
What is the largest part size that you can make with
flexible? That we can make, there is no limit. We can go for 100 square meter, but there is no interest to make a silicone membrane of 100 square meter. We talk about 1,000 square feet. There is no. Honestly, I have done membrane. The biggest one was around 40 square meter, 38, I think. And it starts to be the limit because there is the weight of the membrane. You have to leave the membrane. You have to put on the top of that. This is why we develop more and more this solution with the resin channel and the plastic bag, because then you can use the strategy to introduce the resin by the resin channel, the collapsible channel, but you don't have to handle a too big membrane.
Also, I just wanted to jump in. Sorry, Charles. I think that last slide you threw out was may have gone quickly. I know there's been some questions about the email address. If you look in the chat function, Mackenzie put it in there. It's info@mvpind.com. So info@mvpind.com. You can also go to our website for more info at www.mvpind.com. But it's there in the chat section as well if you need it. Thanks.
And then how does it work with you doing workshops? Is that, I mean, there's a lot to learn here, and there's a lot of steps that you can go through to progress in your knowledge of these processes. How do you work with different companies in training and with workshops?
Thank you to ask this question. So we do at MVP organize training. Okay, that can be the training organized by a distributor, by countries, where we invite customer to come. It's a 3 days training where we have time to produce silicone membrane, to inject, to make part and so on, and to review the full process. Or it can be individual customer training when we go with all the material to the customer and we make the training.
And is there any kind of, limitation to how many people can be there, or, You know, can you work with their
No,
parts and?
except our competitors, people can come, no problem.
Okay.
Yeah, that's one thing, Ginger, that we and everybody that we really love to utilize Charles for, because obviously, as you all saw through the presentation, he is an expert on all things closed mold. So if you are interested, we would love to have a training session, like Charles said, either with through a distributor or with you directly. So you can reach out for details about that as well. Yeah, that's a great question.
And you can do that all over the world, right?
Absolutely.
Yes, absolutely. Yep. We've
I
done
have
them.
done that.
Charles has probably done them in almost every country. So maybe not Antarctica, but pretty much everywhere.
We do have another question. What are the recommended vacuum pressures for perimeter vacuum and assisted vacuum in LRTM?
In light RTM, okay. So normally we work with two different vacuum. One vacuum on the flange to close the mold that we call mechanical vacuum. So we try to have the full vacuum. But for the resin assist flow, we try to work with something like 60% of vacuum according the glass content and the kind of the resin we use. Why? Because we find that more than 60%, the resin start to bubbling. This is the vacuum effect, and that's not good. So we have two different levels of vacuum.
Oh, that's really interesting. My husband's a boat builder, and they saw that effect. They call it champagning when they have the little bubbles all the way through. Yeah.
If one day you have nothing to do, you go with SpaceX on the moon and you try to inject the resin, you will see it's full of air bubble.
Some of your techniques are interesting to me. And then just as I've been around the world and watched different companies, there are some companies that have this philosophy. Well, we want to always, inject within a certain amount of time, and we want the part, done within a certain amount of time. We want to be very consistent. The longer we have an infusion time, the more we feel like there's a chance for error. They also talk about wanting to keep the process very consistent and simple. Can you kind of describe to me a little bit about how you see all of that? I mean, you have so much expertise. I know you said it's important to be organized.
Absolutely. So you have to know first that one of the most important part of my job is to try to make everything simple. To show something on the show, like the GC, like the ACMA, and to make a demonstration on the front of people, something you have developed by yourself, it's easy. But to be sure that everybody can reproduce it is another story. So you have to be sure that the way you develop, everybody can do it. And yes, you are completely right. Even if you have a nice process, you need the right organization around. This is very important. There is part of management and there is part of organization, having the right tools to make the right job and the proper job. Just an example, if you use an injection mat, on the injection mat, you have all the layers in one. So you try to have no waste. So if you have a production with 20 different molds, you will have one person working separately, coming on each mold, trying to make pattern to cut the glass and to save all glass weight as possible. This is part of the organization, and this is part of the money saving when moving from open mold to closed mold. And if you miss this part, even if you have a very good process, it will be hard to make money, I mean. Many of the customers at the beginning were looking for the closed mold process to go for consistency. I mean, every part from Monday to Friday will have the same time of labor and the same quantity of raw material. And now, as I explained on my presentation, they move from one process to another process according their production, according the quantity of them, and according the qualification of the people they have to work with. In layup, you have to be good to doubling the part. In closed mold, you don't need to be good. If you have a checklist, you know exactly what to do. But you need to give the people the right environment to make this job. So never miss that part. Environment around the mold are something very important. And we talk about it during the training.
And I think also that they know why they're doing the certain steps in the process. Sometimes knowing why makes it then more evident to them why you don't do it a different way.
Yes, of course. But, by traveling around the world, you can see different habits, different way to work. And it's very interesting because you don't work in India like you work in South Africa, like you work in Brazil, like you work in USA. But at the end, everybody agree that they need organization around the process.
Yeah, that's a great point, Ginger. And I mean, one of the things, that's great about having Charles come and do a training is really everybody captures that why, why are we doing it this way and being able to replicate it. And like Charles mentioned, everything that we try to implement or develop for a customer is totally production focused. So making it easy for production, making sure they can replicate it is our biggest thing that we want to achieve.
So I would imagine that's part of what comes out of training with you, is they would then be able to work with you to make sure they had that process, those documentations and those steps and how to think about organizing people and where the station should be so that it works.
Yeah.
Okay.
At the beginning, we were talking only about the process, and more we talk about organization, because by giving advice for the organization, we help customer to save time in time.
Okay. And that would be key too, because as you look at one process versus another, that would be another part of what you have to offer. What process fits the best for what they want to do?
Absolutely. But one thing that you may see during the presentation is that at MVP, to avoid extra investment, we try to make everything standard and universal.
Okay.
You can load all accessories on the same insert. That insert can be the one used for silicone and the one used for the light RTM control mold. They are the same. Even on the last fast flow light RTM development, we do the same. We use the same kind of machine. We use the same kind of valve. We don't have to reinvest on everything every time we want to move up on the process.
Okay, that's really important. Okay.
Yes, absolutely.
All right. Well, we're getting up to the top of the hour, and we really appreciate all the questions. I would really encourage everybody on this webinar to reach out to Charles and Drew and MVP. There's so much obviously to be learned. And I think at Composites World, we would like to write more about this kind of project. I find it, just really interesting. So thank you for the presentation today, guys. And thank you to MVP. We really appreciate all of our attendees, and we hope that you'll join us again soon on the next Composites World webinar. Have a great day, everybody.
Thank you very much.
Thank you, everyone.
Bye-bye.